Hello and welcome. Today is day 13 of my 30-day cyber challenge. And today we are back on TryHackMe. We are still working through the Introduction to Cybersecurity learning path, and we are within the Intro to Offensive Security module. I am currently working out of the Web App Security room. So today we're going to kick it off with, I believe, task 2, which is Web App Security Risks. So as usual, I'm just going to go ahead, dive right in. Let's say that you want to buy an item from an online shop. There are certain functions that you would expect to be able to be done on this web app. Most straightforwardly, the online order might go as follows, so just kind of like a suggested general overview. Step 1, log into the website. Step 2, search for the product. Step 3, place that product in the cart. Step 4, specify the address. Step 5, provide payment details. So there are a few main categories of common attacks against web apps, considering the following steps in related attacks. So we have log in at the website, search for the product, and provide payment details. What kind of attack could happen? The attacker can try to discover the password by trying many words. The attacker would use a long list of passwords with an automated tool to test them against the login page. Okay. Search for the product. What kind of attack can happen? The attacker can attempt to breach the system by adding specific characters and codes to the search term. The attacker's objective is to target the system to return data it should not or execute a program it should not. And provide payment details. What kind of attack can happen? The attacker could check if the payment details are sent in clear text or using weak encryption. Encryption refers to making the data unreadable without knowing the secret key or password. So we're not going to cover everything, but we will present a few formal categories from OWASP Top 10. Don't worry if these techniques sound alien to you. TryHackMe walks you through each vulnerability. All right, let's go ahead and just dive right through these. Identification and authentication failure. Identification refers to the ability to identify a user uniquely. In contrast, authentication refers to the ability to prove the user is whom they claim to be. The online shop must confirm the user's identity and authenticate them before they can use the system. However, the system is prone to different types of weaknesses. Example weaknesses include allowing the attacker to brute force, which is try many passwords using automated tools, allowing the user to choose a weak password. A weak password is easily guessed, or storing the user's password in plain text, in which the attacker can manage to read the file containing the passwords, and we don't want them to be able to learn each stored password. That's understood. We also have broken access control. Access control ensures that each user can only access files, which is documents, text, etc., related to their role or work. For example, you don't want someone in the marketing department to access financial records in the finance department. Okay. Examples may include failing to apply the principle of least privilege and giving users more access than needed. So for example, an online customer should be able to view the prices of an item, but not change them. Okay? Being able to view or modify someone else's account by using its unique ID. For example, you don't want a bank client to be able to view the transaction of another client. Fair enough. And being able to browse pages that require authentication. So as an unauthenticated user, being able to browse pages that require authentication as an unauthenticated user. Okay, so for example, we cannot let anyone view the webmail before logging in. Injection. An injection attack refers to the vulnerability in the web app where the user can insert malicious code as part of their input. One cause of this vulnerability is the lack of proper validation and sanitization of the user's input. Cryptographic failures. This category refers to the failures related to cryptography, Cryptography focuses on the processes of encryption and decryption of data. Encryption scrambles clear text into ciphertext, which should be gibberish to anyone who does not have the secret key to decrypt it. In other words, encryption ensures that no one can read the data without knowing the secret key. Decryption converts the ciphertext back into original clear text using the secret key. Examples of cryptographic failures include sending sensitive data in clear text. So for example, using HTTP rather than HTTPS, which is the protocol used to access the web. As we can see, HTTPS is the secure version. Others can read everything you send in HTTP. Didn't know that. Relying on weak cryptographic algorithm. One old algorithm is to shift each letter by one. So for instance, TryHackMe becomes what we see there. This cryptographic algorithm is trivial to break. Fair enough, especially if it's easy to understand. Using default or weak keys for cryptographic functions, it won't be challenging to break encryption used 1, 2, 3, 4 as the key. Okay, these are pretty obvious, I guess. Don't worry if these techniques look challenging or sophisticated at first. TryHackMe has dedicated rooms to help understand. Okay, and let's see what questions we have today. You discovered that a login page allows an unlimited number of login attempts without trying to slow down the user. What is the category of security at risk? Let's see. Probably identification and authentication failure. Let's check that out. Boom. Okay. You notice that the username and password are sent in clear text without. So I would say probably a cryptographic failure. Let's run that. Awesome. All right, so we have got task 2 complete, which means we are complete with today, and we will kick off task 3, which is practical example of web application security tomorrow.